Venus. Other than the moon, it's the brightest object in the night sky, captivating men and women for millennia. Named for the Roman goddess of beauty, the heavenly orb has an ugly side too.
It's a very hellish place. Sulfuric acid at the surface.
Seems to be an inherently volcanic world with an atmosphere that ran amok.
But Earth's sister planet may not have always been so inhospitable.
We think that Venus may once have looked more like Earth in the past.
Now, after decades of neglect, planetary scientists turn their attention back to the solar system's second planet to unlock secrets of our world's past and perhaps what's ahead.
Venus is the once and future Earth.
Prepare to voyage to Venus.
Okay, there we copy. We're proceeding into the IUSPI lock checkup.
NASA is heading out into deep space once again. With an initial price tag of $500 million each, two new programs, DAVINCI and VERITAS, will launch planetary probes designed to visit Venus within a decade.
We hope these missions will further our understanding of how Earth evolved and why it's currently habitable when others in our solar system are not.
By gathering new data about Venus, scientists also expect to learn about Earth and the evolution of life. Two rocky bodies, roughly the same size, astronomical next-door neighbors, both formed about 4.5 billion years ago. How did two worlds with so much in common become so different?
It's this amazing cosmic accident, right? That we have two planets that are so much alike. It's like every scientist's dream that you have like a control case.
Venus is very special. She's the most Earth-like world that we know the least about. She has this massive atmosphere, an atmosphere that is 100 times that of Earth's, which is layered and structured and telling a story that we haven't read yet.
Inspired by the Italian artist Leonardo da Vinci, Garvin and the team created an acronym to name their mission and honor the original Renaissance man.
I was always struck by him. His writings in science, engineering, art, all came together with imaginative creation, some of which even looked like spacecraft that could go to Venus.
Fittingly, now one bearing his name will make that journey, currently scheduled to launch in 2029. The plans include a carrier spacecraft, which will fly by Venus twice before releasing the descent probe, protected by a heat shield 7 feet in diameter.
That will carry us into that atmosphere, handle the peak heating of that entry, and then jettison the heat shield so our probe will be exposed to the atmosphere in the upper clouds, around 70 kilometers. And that's when our mission begins.
That multi-pronged mission to examine the elemental properties of the Venusian atmosphere, image and identify the character of the landscape, and ultimately land on the surface.
We are sending what I like to call a flying rover chemistry lab. And it will be in the form of a special probe, not unlike a diving bell that you would need to go into the deep ocean. That vehicle is designed to handle environmental changes that go from super cold and almost no atmosphere to super hot and high pressure, all in the period of about an hour. That's tough.
Almost 60 years ago, Mariner 2 rocketed planetary science into high gear when it became the first spacecraft to successfully visit another planet with a flyby of Venus. The Soviet Union's Venera missions landed multiple probes on the surface, brief encounters, which exposed the planet's desolation. The Pioneer multiprobe was the last American mission to enter and study the atmosphere of Venus in 1978. And the Magellan spacecraft, deployed from the Space Shuttle Atlantis in 1989, was the first to map the entire surface of Venus, revealing volcanic activity. However, Mars soon stole the spotlight of planetary exploration, in part because of the greater engineering challenges presented by Venus.
Venus presents a very tough challenge. A big atmosphere, hard to get into, hard to survive at the surface, where the pressure and temperature are equivalent to being half a mile deep in the ocean at temperatures that are twice the temperature of your oven.
But the success of the Mars programs serve as scientific building blocks and inform what's possible elsewhere.
What we've done at Mars is shown the next generation of exploration techniques, instruments, vehicles, science questions, computing, models of states of past climates. We can now apply what we've learned at Mars and at Earth to Venus. What a perfect time.
Including cutting-edge capabilities ready to be employed by these two missions, VERITAS and DAVINCI. This is the first full-scale titanium test unit of DAVINCI, about 1 meter across.
We've tested this to 450 degrees centigrade and have confirmation that our instruments inside this, which look like this at small scale, all packed in there underneath this outer pressure vessel, will do well. You can see one of the inlet systems here that will be ingesting gases multiple times through the transect of the atmosphere, some in the clouds, and then every couple hundred meters as we come out of the clouds. So we'll be literally tasting Venus all the way down using a system like this.
The 5 primary science instruments will work like the 5 senses of the human body. 2 analytical spectrometers to pinpoint the chemical composition of the atmosphere. The Venus Atmospheric Structure Investigation, or VASI, which will measure winds, pressure, and temperature. A student experiment named VFOX to investigate the cycle of small levels of oxygen in the atmosphere, and the Venus Descent Imager, known as VENDI, located at the bottom.
The instruments need to fit together, almost like jigsaw puzzles, to make the most of the volume that we have within this very special envelope of our descent sphere. We're going to take a lot of that instrument capability and apply it to the big questions about Venus.
Questions that scientists have been posing for years. In many respects, the investigations of Mars and Venus are looking for the same thing: evidence of water present today, or perhaps long, long ago.
We want to understand if Venus, which we think of as Earth's evil twin, was more like her identical twin in the distant past.
That means vast surface oceans that could have harbored life.
While life on Earth was arising and evolving, it's possible that Venus was also a place that those processes could happen. We're going to look for chemical fingerprints that may indicate that Venus was once habitable in the past. So by reading these records on Venus today, we might be able to infer that Venus was a nice place to live in the past, maybe a place that we'd want to visit.
Understanding Venus's story can aid the search for life outside our solar system, as astronomers discover new planets around other stars.
By studying Venus and discovering if it was truly habitable, we might discover that the habitable zone boundaries are fuzzy. Maybe you can have habitability beyond those boundaries in ways that are surprising.
High-resolution images will help categorize the makeup of Venus's surface materials.
We want to look for things like granites. Granites are really interesting because, at least on Earth, they form from water-rock interactions and also continent-building processes.
DaVinci's camera work will include more than static landscapes. VENDI will create dynamic 3D relief models at an incredible meter in scale, layering images taken all along its descent. A system already successfully tested by matching the probe's drop speed in a helicopter. Vendy will be looking out the south pole of the probe, what the team calls the Eye of Venus, a window made of sapphire.
This little piece is a really important piece of hardware. We've tested this in Venus-relevant conditions, and it works great. As the probe is falling through the atmosphere, this is what the camera is going to be looking through, and we're going to get spectacular views of the surface. We're going to be taking thousands of images all the way down to the surface. We're going to be able to distinguish different mineral types, which is very exciting once we get below the cloud deck.
You might think this is a small window. I don't know, it looks pretty big to me. This is going to be a new world exposed.
If DAVINCI will explore Venus close up, VERITAS, launching in 2028, will examine the planet from a distance, in orbit.
We will enhance the science that can be obtained from both missions by having these two missions together. So we can compare the visual images that they will take to our radar images, and that will enhance our ability to interpret the radar images, just as the global context that we provide enhances their ability to interpret their local observations.
3 decades ago, 𝗥𝗲𝗀 collaborated on the successful Magellan mapping mission. Now using radar technologies developed to study Earth, VERITAS will return data from Venus 100 times more detailed than its predecessors.
The science that VERITAS wants to accomplish is looking at the planet holistically. We want to understand what makes rocky planets tick. We wanted to understand the geologic engine inside the planet, how that interacts with the surface, how it drives volcanism, how it drives faulting, and what that means for the atmosphere.
Examining landscape features also found on Earth, like fault lines, volcanic calderas, and lava flows. And searching for evidence of subduction. That's when tectonic plates edge under one another into the hot molten interior. VERITAS will test theories about the formation of continents.
VERITAS will help us tell Earth's origin story. That process of subduction led to the formation of continents. Continents may have changed the composition of the oceans.
Ultimately, though, it's about the water here on Earth and there on Venus. So VERITAS will employ a spectrometer designed to see through the clouds and map rock composition, also looking for granite, like here on Earth.
By looking for the chemical fingerprints of continental analogs on Venus, we will also be pinning down that history of surface water. We'll get a better idea of how old those continents are, if they have the right composition to have formed in the presence of water. And we'll also look for water coming out of the interior today. That would be just hugely important for understanding the evolution of the history of water on the surface and in the atmosphere of Venus.
But those ancient oceans are long since gone, and the teams of VERITAS and DAVINCI want to know why.
Why the divergent pathway relative to our Earth? Why didn't she stay cool and neat and oceanic? What went wrong? What went right for her history? How can we disentangle that history? Because that's important.
It may be that Venus is a magic mirror that's reflecting the future of Earth back to our planet. So these same processes involving, the shutdown of geological activity as the planet cools, these are also going to play out on Earth billions of years into the future.
Understanding Venus better should cast light on Earth's present and future states too.
We can validate and improve our climate models that we're using to study climate change here on Earth by applying those models to Venus. The Venus system is different, it's a lot more extreme, but if our models, when we take them from Earth and we apply them to Venus, if they don't break, then that means those models are more robust.
Some have theorized, as the oceans boiled away, microorganisms may have migrated to the upper levels of the cloud decks. In 2020, an international team of researchers announced the discovery of small levels of phosphine, a potential biosignature in the Venusian atmosphere. Analysis was reached using Earth-based radio telescopes. Questions about the phosphine news persist, and even the lead researchers suggested the best way to test their results was to go to Venus.
So it may be that the only thing to do is to send a spacecraft that can really sample and see if there are life forms there.
Now that's something VERITAS and DAVINCI will do, providing an unprecedented data to learn from.
The experts that build the models can test their theories with real data.
If there are intriguing chemical signatures there, we will be able to confirm that they're there, but also understand the context of the environment that we found them in.
The piece that VERITAS will contribute to is understanding volcanism. That's that one hypothesis that has been put forward as a way to produce phosphine in the atmosphere.
For those involved with these new missions to Venus, the green lights validate years of persistence, passionate work, and proposal refinements.
Doing planetary science as a career takes a lot of patience, and it takes a lot of fortitude.
This is beyond words. We are so ready to bring Venus into focus for humanity because we think she is a story we have to tell.